Hey, today you are going to learn how to factor something completely new. So we factored several times throughout the year, and most of it you learned in Algebra 1, and then we just refreshed your memory. But today we got something new. It's called a sum and difference of cubes. Now, this is only for something with two terms, just to show you. 1, 2, 1, 2, 1, 2, 1, 2. So when something has two terms, before we looked to see if it had a GCF, either it did or it didn't, and then we looked to see if it was something called a difference of squares. But today we have something new called a sum and difference of cubes. So let's talk about our perfect cubes. So 1 times 1 times 1 makes 1. That's a perfect cube. 2 times 2 times 2 makes 8. That's a perfect cube. 3 times 3 times 3 makes 27. That's a perfect cube. 4 times 4 times 4, that makes 64. That's a perfect cube. 5 times 5 times 5, 125. 6 times 6 times 6, 216, etc. So these are all perfect cubes because if you take the cubed root of them, you get pretty little whole numbers. Now, just to show you how to put a cubed root in your calculator, you go to this button that says Math, and then you go down to number 4, and let's say I want to take the cubed root of 216 because I don't know what that is. And you see it's 6. If I wanted to take the cubed root of 27 because I don't know what that is, I see it's 3. So these are perfect cubes because when you take their cubed root, you get a pretty little whole number. Now, variables. You see we have variables down here. So variables, it doesn't matter what the variable is, but the exponent has to be a multiple of 3. 3, 6, 9, 12, etc. So exponents have to be multiples of 3. Okay, so this is the formula for how a sum of cubes factors, and this is the formula for how a difference of cubes factor. So notice the formulas are basically the same. They both have the same letter configuration, but the signs are different. So notice whatever this sign is, this guy, it's the same. And then the next one's different. And the last one's a plus. So whatever this is, it's the same, then it's different, and then it's a plus. Well, let's see, does it hold true? Yep. First it's the same. So the same is what we start with. Then it's different. And then it's a plus. Same, different, plus. Okay, so I have a song for factoring sum and differences of cubes, and it's to the tune of Mary Had a Little Lamb. Okay, the letters go A, B, A squared, A, B, B squared. The signs go same, different, plus. That is how they go. The letters go A, B, A squared, A, B, B squared. The signs go same, different, plus. That is how they go. So that is to help you when you are factoring a sum and difference of cubes. So now we just have to figure out what A is and what B is, and then we'll be able to use the formula. Okay, so let's come down here. Remember, your first rule is to always look for a GCF, but they don't both have x's, and nothing can divide into 1 and 1,000 besides 1, so that's out. Then when there's two terms, 1, 2, you want to see if it's this thing that you already know about called a difference of squares. But when it's a difference of squares, the exponent has to be even, 2, 4, 6, 8, so that can't possibly be a difference of squares. So now we check the new thing, a sum or difference of cubes. Well, I've got a minus, so it'd be a difference. My exponent's a multiple of 3. Let's see if I can take the cubed root of 1,000. So I go to Math, down to number 4. And let's see, the cubed root of 1,000. Sure enough, it's a 10. Okay, so we're going to figure out who A is, and we're going to figure out who B is. And they're always going to be positive. Okay, as soon as I do my same different plus, that takes care of the sign issues. All right, so B is the cubed root of the 1,000, and we know the cubed root of 1,000 is 10. And that's because 10 times 10 times 10 makes 1,000. And then the cubed root of x cubed is x, because x times x times x makes x cubed. So A and B are the cubed roots of these numbers. Okay, so now that I know who A and B are, I can follow my formula. Okay, so first I'm going to get it just right in front of our faces. So I'm going to sing my little song. The letters go A, B, A squared, A, B, B squared. The signs go same, different, plus. That is how they go. Okay, so we have our little baby set of parentheses and then our big set of parentheses. Now, let's do exactly what the formula tells us to do. First, it wants A. Well, A is x. Then it wants B, and B is 10. Then it wants you to take your A and square it. So x times x, that's x squared. Then it wants you to take A times B. So x times 10, that's 10x. And then it wants you to take B and square it. So 10 times 10, and that's 100. And then the signs go same, different, plus. So whatever this starts out as, it's same, different, plus. Now, in the past, whenever we've had something with 3 terms, 1, 2, 3, we've tried to A times C rooftop it, and it would be an easy one, but this will not factor. So if I did try to take A times C, 1 times 100 would be 100. I'd want the numbers to add to make 10. So I would be looking for 2 numbers that multiply to make 100 and add to make 10. 1 and 100, 2 and 50, 4 and 25, 5 and 20. Nothing. Nothing works. There is nothing that multiplies to make 100 and adds to make 10. So this guy in the back, it looks like it factors. A times C rooftop, easy one, but it won't. It won't ever. So that's it. That's our answer. So whenever you factor a sum or difference of cubes, it's always going to look like this when you're done. Okay, next one. So first I look to see if I have a GCF, but they don't both have x's and nothing can divide into 8 and 1 besides 1. Okay, difference of squares. Not an even exponent, so move on. So let's see if it's a sum or difference of cubes. My exponent's a multiple of 3. 8 and 1 are in my perfect square list, so I'm good to go. All right, so let's figure out who A is, and let's figure out who B is. Okay, so A is the cubed root of this number right here. What times what times what makes 8? 2. 2 times 2 times 2 is 8. And you see up here that the cubed root of 8 is 2. And then to get x cubed, x times x times x makes x cubed. So this is the cubed root of 8x cubed. Now, what's the cubed root of 1? What times what times what makes 1? Well, 1 times 1 times 1 is 1. Okay, so now I have A and now I have B. Okay, so I'm going to write my formula down like I did the last time. I think the more you practice it, the more you remember it. So baby set of parentheses, big set of parentheses, and then I'm going to sing. The letters go A, B, A squared, A, B, B squared. The signs go same, different, plus. That is how they go. All right, so I have my little baby set of parentheses and my big set of parentheses. Okay, first I want A. So A is 2x. Then I want B, and B is 1. Now I want to take a and square it. So what is 2x times 2x? 4x squared. Then I want to take a times b, so 2x times 1, that's 2x. And then b squared, 1 times 1, and 1 times 1 is 1. And then the signs go same, different, plus. So it started off as a minus, so same, different, plus. Now, just to show you one more time, if I tried to a times c rooftop this one, now this one wouldn't be the easy one, but if I tried to a times c rooftop, a times c, 4 times 1, that's 4, and you'd want the numbers to add to make 2. So can you think of two numbers that multiply to make 4 and add to make 2? 1 times 4, 2 times 2, nothing. Nothing multiplies to make 4 and adds to make 2. So this is our answer. Okay, so I'm not going to keep checking it. I'm just going to tell you from now on, this trinomial in the back will never a times c rooftop. Ever, ever. Okay, number 3. All right, first I look for a GCF, but nothing can divide into 64 and 27 besides 1. They don't both have x's. Okay, it's not a difference of squares. It doesn't even have a minus sign. So, on to our new guy. Sum or difference of cubes. I've got a sum. My exponent's a multiple of 3, and 64 and 27. Sure enough, they're in my perfect cube list. Okay, so let's figure out A, and let's figure out B. Now, do you know who A is? What's the cubed root of 64x cubed? 4x. 4 times 4 times 4 is 64, and x times x times x is x cubed. How about B? The cubed root of 27 is 3, because 3 times 3 times 3 is 27. Okay, so I've got my little baby set of parentheses, and I've got my big set of parentheses. And the formula goes, the letters go A, B, A squared, A, B, B squared. The signs go same, different, plus. That is how they go. Okay, so little baby set of parentheses and big set of parentheses. Okay, first I want A, and A is 4x. Then I want B, and B is 3. Now take A and square it. What's 4x times 4x? 16x squared. Now take A times B. 4x times 3. 12x. And now take B and square it. 3 times 3. 9. And then the signs go same, different, plus. So this time it started out as a plus. So same, different, plus. And there it is. This is how you factor a sum and difference of cubes. It looks kind of scary, but it really isn't. Once you know what A and B are, then you just do exactly what the formula says. Okay, let's jump down to number 5. So number 5 is different because it has a GCF. Who can divide into 2 and 54? 2 can. Okay, so that's our GCF. Remember, every time there's a GCF, you build one set of parentheses back behind it. So 2 times what gives you back 2x cubed? X cubed. And 2 times what gives you 54? 27. Okay, now let's ignore this GCF. I'm just going to cover him up with this pen right here. And now let's look in the parentheses. I know it's not a difference of squares because there's not a minus, but it looks like a sum of cubes. I've got an exponent that's a multiple of 3, and 27 is a perfect cube. Okay, so I've got my little baby set of parentheses and my big set of parentheses. Okay, I'm not going to write the formula this time. I'm just going to look right up here. First it wants A. Oh, we need to figure out who A and B are. Oh my gosh, I jumped the gun. Okay, let's figure out who A is and let's figure out who B is. Okay, who do you think your A is? X. X times X times X makes X cubed. Who do you think your B is? 3, because 3 times 3 times 3 is 27. Okay, so it is very important to find A and B. Now let's do exactly what the formula says. Okay, first it wants our A, and we said A is X. Then the formula wants B, and our B is 3. Then it wants A squared. So X times X, X squared. Then it wants AB, A times B. So X times 3, 3X. And in the back, it wants B squared. 3 times 3, 9. And then the signs go same, different, plus. So this one started out as a plus. So same, different, plus. And then this GCF I've been covering up, don't forget to drop him. Shoo! And that's our answer. So basically like the others, we just had a GCF to take out at the very beginning, and then we do it like all the others. Okay, just because the next few problems are going to take a while, I think we'll just skip and go straight to them. So this page, all I did was factor. Now we're going to solve. Okay. So this says solve the following equations by factoring. So we're going to factor like we did on the front page. But then, because this back guy does not A times C rooftop, I am going to have to solve by using the quadratic formula. Okay, so that's one reason why it takes a little while. I wouldn't say it's extremely difficult, and we've done the quadratic formula before. It just takes a little bit. Okay, so with these problems, they do need to say equals 0 before you begin. So as long as they say equals 0, you're ready to start. We always start looking for a GCF when we're factoring. Does this one have a GCF? Yeah, 2. 2 can go into 2 and 2. All right, so let's factor out our GCF. So 2 times what makes 2x cubed? 2 times x cubed. And 2 times what makes 2? 2 times 1. Okay, let's ignore that GCF for a while. I'm going to cover them up. Inside, it's got 2 terms, 1, 2. I know it's not a difference of squares. There's not even a minus. So let's check for our new guy, our sum or difference of cubes. And this is a sum of cubes. My exponent's a multiple of 3, and 1 is a perfect cube. Okay, so we need to figure out A, and we need to figure out B. Do you know who A is? X. X times X times X is X cubed. And do you know who B is? 1. 1 times 1 times 1 is 1. Okay, so little baby set of parentheses and big set of parentheses. Okay. Should I write down the formula one more time on this page? I'll do it. The letters go A, B, A squared, A, B, B squared. The signs go same, different, plus. That is how they go. Okay, so I've got my little baby set of parentheses and my big set of parentheses. So first I want my A. Well, who's A? X. Then I want B. That's a 1. Now take A and square it. X times X, X squared. A times B. X times 1, 1x or X. And then B squared, 1 times 1 is 1. And then I'm going to drop my GCF. Okay, so I have finished factoring, but now I have to solve, which I have not done until this point. Okay, so my little equals 0, I'm going to bring that down, and I'm going to solve. I'm sorry, I got distracted by my son. I still need to do my same, different, plus. So whatever this sign is right here, it's same, different, plus. so now I need to solve. So one thing we haven't talked about that you need to know, whatever the highest exponent is, that's how many answers you should have when you're done. So I should have 3 answers total when I'm done. So first I'm going to set my first factor 2 equal to 0. But there's not even a letter here to solve for. And 2 doesn't equal 0. That doesn't make sense. So let's get rid of that. Next, I'm going to take my second factor, x plus 1, and set it equal to 0. Now this equation I can solve for. What do you think you would do to get x by itself? Subtract 1. You get rid of addition with subtracting. And what do you get if you subtract 1? -1. Okay, that's one answer. I need 3 answers total because that's a 3. So I need to find the other 2. Now, because this guy back here will not a times c rooftop because it won't factor, I'm going to have to use the quadratic formula. So I need to remind you about that. X equals the opposite of b plus or minus square root b squared minus 4ac all over 2a. Okay. Full of songs in this lesson here. So right now I am working on solving this quadratic right here. All right. So when I did quadratic formula with you before, the first thing we did off to the side was figure out who a, b, c, and b squared minus 4ac are. Okay, so I'm going to do the same thing with this as well. So do you remember who's a? A is 1. That's the number in front of the x squared. Who's b? B is -1. That's the number in front of the x. And who's c? C is the constant. Remember, it just goes in order. This is the a, this is the b, and this is the c. Remember? Okay, now I need to calculate b squared minus 4ac. Now, this is when I use my calculator to help me. But we need to have parentheses where the b is. We need to have parentheses where the a is and parentheses where the c is, or the calculator won't give us the right answer. Okay, so we already said b was a -1. We already said a was a +1. And we already said c was a +1. Okay, so I'm going to put this in my calculator just like I wrote it on my paper. Okay, so parenthesis, -1, close it, square it. This is a minus sign, so minus 4 parenthesis 1, parenthesis 1. So this is a -1, but this is a minus. And we get -3. Okay, now we have everything we need to know to be able to complete this. Okay, so looking at my formula, it starts off x equals. Now it wants the opposite of b. What's the opposite of a -1? A +1. Plus or minus square root. Now it wants my b squared minus 4ac, and we just found that to be -3. And then all over 2a. So it wants me to take 2 times my a. Well, what's 2 times our a? What's 2 times 1? 2. Okay, once we get this far, our goal is to start working on this radical. So do you remember? Who takes the negative out of a radical? I does. And then you're left with a positive square root of 3. You can't take the square root of 3. You can't break it down. Okay, so that's as good as that gets. So I'm going to rewrite this. 1 plus minus. This is getting replaced with I square root of 3. And I recopy all over 2. Now at this point, I would look at my 3 front numbers, which are 1, 1, and 2. And if I could divide them all by something, I would. But I can't. So that's it. And these are my remaining 2 answers. So one answer is 1 plus I square root of 3 over 2. And the other answer is 1 minus I square root of 3 over 2. So I have 2 answers just smushed together here. So here's 2 answers. This one was my third answer, which is what I wanted, was 3 answers total. Okay, kind of overwhelming, but that's it. Okay, let's go down to number 3. Number 2 is exactly the same, but let's just jump down to number 3. Okay, so first I look for a GCF. There is not one. It looks like a sum of cubes. 8's a perfect cube. Exponent's a multiple of 3. 125 is a perfect cube. Okay, so if it is a sum or difference of cubes, the first thing we need to do is identify our A and identify our B. Now, do you know who A is? 2x. You're looking for the cubed root of 8x squared. And 2 times 2 times 2 is 8, and x times x times x is x cubed. Now, how about B? 5. The cubed root of 125 is 5, because 5 times 5 times 5 is 125. Okay, so I'm going to go ahead and write this formula down. I don't think it hurts for us to say it as many times as it takes. So the letters go A, B, A squared, A, B, B squared. The signs go same, different, plus. That is how they go. Okay, so I've got my baby set of parentheses and my big set of parentheses. Now, let's plug in exactly what the formula is telling us to do. So, who's A? 2x. Okay, who's B? 5. Okay, now how about A squared? 4x squared. 2x times 2x is 4x squared. Okay, how about A times B? 10x. 2x times 5, that's 10x. And then how about B squared? 25, because 5 times 5. And then the signs go same, different, plus. So this is starting out with a plus. So same, different, plus. Okay, so now it's factored. So now I'm ready to solve. So this whole equals 0 business, that's the part I'm getting ready to work on. So I know I'm going to have 3 answers when I'm done. And that's because the highest exponent is a 3. So I take my first factor and set it equal to 0. And then I'm going to solve this equation. So what would you do to solve this equation? First, you would subtract 5 because you get rid of addition with subtraction. The 2x drops. How much is 0 minus 5? Negative 5. And then how do you get rid of the 2? You divide. But you can't divide negative 5 by 2. You can't reduce it, so we just leave it. So one answer is negative 5 halves. So there's one answer, and now I'm going to find the other 2. And because this guy will never A times C rooftop, I have to solve it with quadratic formula. Okay, so let's figure out who's our A, who's our B, who's our C, and who's our B squared minus 4AC. Okay, so right now I am focusing on this quadratic right here that does not factor. So who is the A of that? The A is 4, because that's the number in front of the x squared. Who's the B? Negative 10, because that's the number in front of the x. And who's the C? 25, because that's the constant, the number without the variable. Okay, so now to calculate B squared minus 4AC, I'm going to need to have parentheses where my B is, parentheses where my A is, and parentheses where my C is when I use the calculator. So B, we said, was negative 10. A, we said, was 4. And C, we said, was 25. Okay, so I'm going to type it in my calculator just like that. All right, so I've got parentheses, negative 10, close it, square it, minus, this is always a minus, 4, parenthesis 4, close it, parenthesis 25. Oops. Close it. So negative 10 squared minus 4, parenthesis 4, parenthesis 25. And we get negative 300. Okay, so now I'm ready to do exactly what the quadratic formula tells me. Okay, so I'm going to sing that song again, just so we have the formula. So it goes, X equals the opposite of b plus or minus square root b squared minus 4ac all over 2a. Okay, so now let's do exactly what it says. So first it says take the opposite of b. So what's the opposite of a negative 10? A positive 10. Plus or minus square root. Who did we find b squared minus 4ac to be? Negative 300. All over 2a. So 2 times a. What do you get if you take 2 times your a? 8. 2 times 4 is 8. Okay. Once I'm to this point, I start working on simplifying my radical. So once again, I have a negative under there. So who's going to take the negative out? I. And then I'm left with a positive 300. Now, I can't take the square root of 300 and get something pretty, so I'm going to try to break it down. So this is a square root, so you need to be thinking about perfect squares. So remember, you've got 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10. Any of those jump out at you that can go into 300? And if so, you want the biggest. Well, it's this guy, 100. 100 goes in there how many times? 3 times, because 100 times 3 is 300. And then what's the square root of 100? 10. So it's 10i square root of 3. Okay, so I'm going to rewrite it, and I'm going to replace my square root of negative 300 with 10i square root of 3. Okay, so I've got 10 plus minus. I'm going to replace this with 10i square root of 3 all over 8. Now this time, let's look at those front 3 numbers. Can I divide these front 3 numbers all by something this time? Yeah, I can divide them all by 2. So let's do that. So what is 10 divided by 2? 5. Put your plus minus. What's 10 divided by 2? 5. Okay, division bar. What's 8 divided by 2? 4. And the I square root of 3, we just recopy that. And here are my other 2 answers. One answer is with the plus, one answer is with the minus. So 2 answers right here and 1 answer right here for 3 total answers. And that is our lesson on a sum and difference of cubes. I hope you understand. Smiley face.